Topic is, or our first topic, is to talk about the names and formulas for writing out our covalent compounds. And so the big thing with covalent compounds, remember these are compounds that are between two nonmetals. And therefore, because there's no transfer of electrons, that does mean that there's no ions that are actually formed, which means that our first point here is that there's no actual charges that need to be balanced out. And so we already kind of mentioned this. This forms between two nonmetals. And so in this process, that does mean that there's no transfer of electrons. And so since there's no transfer of electrons, it makes our life easier, which means that instead, we just get to use subscripts to show the number of atoms that are present for each element. Now, just a note, when the element in the beginning of the formula is a single atom, the prefix mono is omitted. Then the ending of our second element is always going to end in "ide." So that's the big thing, is it still gets that "ide" ending. And so let's talk about our prefixes here. And so for our prefixes, we have 10 of them that you guys need to worry about. And the first one is mono, right? Like if you think of the phrase mano y mano, it's like one-on-one. Now remember, we're going to label this second element only. All right, after that, 2 is di, 3 is tri, 4 is tetra, 5 is penta. So hopefully you guys are starting to catch on. Like triangle is a shape with 3 sides. Pentagon is a shape with 5 sides. So it is very similar to some of the things or some of the words that you guys already are familiar with. Then for 6, this is hexa. Now 7 is actually hepta, which is a little bit different. A lot of you guys probably were thinking it's septa. It is not septa, instead it is hepta. Then 8 is octa, 9, nona, and 10 is deca. So these are the prefixes that we use when it comes to naming or writing out the formulas for our our covalent compounds. And so let's look at some examples. So first up, we have CO2. Now, a lot of you guys could probably tell me this is known as carbon dioxide, right? So we have carbon, and then remember, since there's only one carbon according to the formula, that's why there's no number there. It's just regular carbon. And then 2, we said 2, the prefix is di, and then it's dioxygen, so dioxide. All right, let's look at another formula maybe some of you guys are also familiar with. Here we have CO. So since there's no little subscripts, that tells us it's 1 carbon and 1 oxygen. Now, carbon stays the same, but here, because it's the second element, this is where we would use the mono prefix. So this is carbon monoxide. Again, 2 things that you guys have probably heard and seen, maybe even seen the formulas for before. And so that's how we get those names. Now let's look at some other examples that maybe you guys haven't seen before. So our next one is P2O5. So P2 is the first part. So 2 is di. So it's diphosphorus. And then O5, so 5 is penta. So it's pentoxide or pentaoxide, whichever you'd prefer. Then next up, we got H2O. Now, a lot of you guys can tell me it's water, right? But here, since it's 2 H's, we call this dihydrogen. And then the O would be, since there's only one of them, monoxide. And this actually kind of reminds me of a funny story. So years and years ago, there was two radio personalities who on April Fool's Day decided to make a public service announcement saying that dihydrogen monoxide needs to be banned, and it's all over the place. It's in schools. It's poisoning children. Kids are dying because of it. And eventually, the show got called and bombarded with calls, and schools were getting called to be told to be shut down, all because of these radio personalities just playing a joke on April Fool's Day saying we need to ban water. So anyways, just a fun little story in terms of understanding, how this naming stuff works. Otherwise, our next example, unfortunately, doesn't have a funny story, but it does have an important point. So we have SO3. Now, SO3, so it's one sulfur, so we would call it just sulfur. Remember, mono isn't used. And then it's O3, so there's three oxygens, so trioxide. Now, this is where you have to be careful, because as you get more familiar with the polyatomic ions, SO3 is actually also a polyatomic ion. Now, the difference here is SO3 as a polyatomic ion has a -2 charge, where this SO3, notice there's no charge. So SO3 without a charge is sulfur trioxide. SO3 with this -2 charge as a polyatomic ion is sulfite. So keep in mind, the charge does have a huge role when it comes to naming these things. So if there is a charge, it's a polyatomic ion. No charge, it's a covalent compound. All right, our next one, we got C4H9. So the C4 part would be tetracarbon. And then the H9 part, so 9 is nana, so it would be nonahydride. All right, so now let's look at going the other way, taking the kind of written name and writing out the formula for it. So remember, it all just comes back to the prefixes. So our first example here, we got phosphorus. So notice there's no prefix, so it's just phosphorus. And then trioxide, so it's telling us it's O with 3 after it. So this one is PO3. All right, let's look at another one. We get carbon tetrachloride. And so again, there's no prefix in front of carbon, so it's just C. And then we have tetrachloride. So tetra is 4, and then chloride is Cl. So CCl4. All right, let's look at another one. Now we got disulfur. So disulfur means S2. And then pentoxide would mean O5. Last example here. So we got tetraiodine decoxide. So the tetraiodine says that it's I4. And then decoxide, so deca, remember, means 10. So it's O10. All right, that's it for this video. Go ahead and keep working on the practice page. I'll see you guys on the next one.